Greetings! This video is about data warehouse schema designs. We will explore how to optimize data organization for analytics and reporting. We'll be covering star, snowflake, and galaxy schemas. Let's begin with the star schema. Key characteristics of the star schema include a central fact table connected to dimension tables. It is denormalized for query performance, meaning data is duplicated to speed up access. It has a simple structure with minimal joins, which also contributes to faster query execution. Star schemas are optimized for online analytical processing, OLAP operations, which are designed for fast data retrieval and analysis. They offer faster query execution, but with some redundancy due to the denormalized nature. Here is an example of a star schema implementation using SQL. A fact table called sales_fact is created. It includes columns such as sale ID, time ID, product ID, customer ID, store ID, quantity, and amount. Foreign key constraints link the time ID to the time dimension table and the product ID to the product dimension table. The fact table contains the business metrics, such as quantity and amount, and the foreign keys to all the dimension tables. Each dimension table has a primary key that is referenced by the fact table, creating the characteristic star pattern. Queries join the fact table with relevant dimension tables to analyze data across different business perspectives. Now let's discuss the Snowflake schema. Snowflake schemas feature normalized dimension tables. This means that dimension tables are split into multiple related tables to reduce data redundancy. While this approach saves storage space and improves data integrity, it requires more complex joins when querying the data. Snowflake schemas are better suited for scenarios where data integrity and maintenance are critical. In Snowflake schema diagram, you can see fact table in the center with dimension tables connected to it. Dimension tables are further connected to subdimension tables. Let's see how the Snowflake schema is implemented using SQL. In a Snowflake schema, dimension tables are normalized into multiple related tables. The example shows how the product dimension is split into product_dimension and product_category tables. This normalization reduces redundancy, but requires more complex joins when querying the data warehouse. Now let's explore the galaxy schema. Galaxy schemas involve multiple fact tables sharing dimension tables. This type of schema is also known as a fact constellation schema. Galaxy schemas support complex business processes. Galaxy schema enables analysis across multiple business areas. They combine the benefits of both star and snowflake schemas. The diagram shows two fact tables, sales fact table and inventory fact table, sharing multiple dimension tables like time dimension, product dimension, customer dimension, and store dimension. Here is an example of a galaxy schema implementation using SQL. A galaxy schema contains multiple fact tables that share common dimension tables. In this example, both sales_fact and inventory_fact tables share the time and product dimensions. This structure enables integrated analysis across different business processes while maintaining data consistency. Now let's compare these schemas. The star schema features a single fact table with denormalized dimensions, while the snowflake schema has a single fact table with normalized dimensions. The galaxy schema, on the other hand, involves multiple fact tables sharing dimensions. In terms of query performance, the star schema excels due to fewer joins, while the snowflake schema offers good performance but requires more joins. The galaxy schema's performance varies depending on query complexity. Data redundancy is high in star schemas, low in snowflake schemas, and moderate in galaxy schemas. Maintenance is easier for star schemas but becomes more complex for snowflake and galaxy schemas, with the galaxy schema being the most complex. Storage requirements are higher for star schemas, lower for snowflake schemas, and moderate to high for galaxy schemas. Star schemas are best suited for simple data marts with a priority on query performance, while snowflake schemas are preferred when data integrity and storage are priorities. Galaxy schemas are ideal for complex enterprise data warehouses. Here are some guidelines for selecting the right schema. Choose the star schema for simpler data models and faster query performance. Use the Snowflake schema when data normalization and storage efficiency are priorities. Implement the Galaxy schema for enterprise-wide data warehouses with multiple business processes. Design schemas based on the most common query patterns, and document schema design decisions and maintain metadata. When selecting a schema, evaluate query performance requirements versus data integrity needs. Consider data volume and expected growth patterns. Assess ETL, extract transform load, complexity for each schema type. Analyze reporting requirements and user query patterns. Balance maintenance overhead with business value. In summary, the star schema is a denormalized design with a central fact table connected directly to dimension tables, optimized for query performance with simpler joins. The Snowflake schema features normalized dimension tables to reduce redundancy, better for data integrity and storage efficiency, but requires more complex joins. The Galaxy schema has multiple fact tables sharing dimension tables, supports complex enterprise data warehouses with multiple business processes and integrated analysis. As next steps, analyze your business requirements to select the appropriate schema. Design dimension and fact tables based on reporting needs. Implement ETL processes to populate your data warehouse. Optimize schema design based on query performance metrics. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.